Hello everyone and welcome to the OneClass channel. My name is Donna Riel and I'm a recent master's graduate from the Materials Science program from University of Ontario Institute of Technology, also known as Ontario Tech University. I also took my Bachelor's of Science at this institution as well in the Pharmaceutical Chemistry program. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. And I'm just going to get started on our set of questions in today's session. Okay, so question 1 asks, what is the electron configuration of carbon? So first I'm going to write down the definition of electron configuration, since it might be a new term for some of the viewers. Electron configuration is the distribution of electrons in atomic or molecular orbitals. So there are different steps that we can take in order to find the electron configuration of a certain atom. So I'm going to write down the steps right now. So step 1 is to divide the periodic table into atomic orbital sections. So I just looked up on Google an example of this. So here are all the electron configurations in the periodic table. In the light blue section here, and also helium, this is from the s orbital. The green section over here is the p orbital. The middle part of the periodic table is D. And the last two rows, the lanthanines and actinides, are the f orbital elements. So this brings us to step 2, where you just move from left to right across the rows. And you start at hydrogen. And then when you write it down, you write the row number, then the block letter. So this will make more sense when I do the example for the question. Step 3 just says that when you get to the D part of the periodic table, so for the D orbitals, the D block, the row number will be -1. And similarly for the F block orbitals, it's the row number -2. So let me write down the example for carbon. Excuse me. Okay, so for example, for carbon, go back to the periodic table. So first let's find carbon on the periodic table. It's right here where the mouse is. So starting from hydrogen and going from left to right, I first write down the row number. Just say carbon. So the row number starting at hydrogen is 1, and then its block letter is S. And then going across, helium is also in the 1s orbital. And to show that there are 2 electrons, helium, the 2 in helium and the 1 in hydrogen, I put 1s2. So you can think about each extra electron as one of the numbers in the superscript. Okay, so 1s2, and then going back to the row number 2, it's going to be 2s2. So this shows the lithium and the beryllium. And then going across to 2p, and then going to count up to where the carbon is. So 1, 2 is where carbon is. So the electron configuration for carbon is 1s2, 2s2, 2p2. I'll also write a note that for some transition metals, a filled d orbital is more stable than when you have a partially filled. So sometimes when you have an ion, and let's say it ends in 4s1, 3d9, or 4s2, 3d8. You can also write it as 3d10. So sometimes that is the preferred electron configuration. That's just an example. But let's see what the junior tutor said. Carbon is in group 14. Group 14 elements have 4 valence electrons. Carbon is in period 2, meaning the highest energy level is 2. Each energy level there is 1 s orbital and 3 p orbitals, except n equals 1, which only has 1 s. S orbitals have a maximum of 2 electrons, and the 3 p orbitals can have a maximum of 6, so the electron configuration of carbon is equal to 1s2, 2s2, 2p2. Yep, so this solution is correct.